Hi everybody, we are going to be talking about the product rule and the quotient rule to start with. Now these are two very important rules and we're going to be using these all the time. So the product rule, obviously product means that you multiply something and that's your answer. So what we're going to be doing is figuring out when to use the product rule, and then once we figure out when it applies, to actually do it correctly. So here's the product rule, and really what it's saying is this. If any function has two things being multiplied together, for example, okay, and we're trying to take the derivative of this function. Well, what we're going to be doing is we're going to be taking the derivative of 1 times the original second, and then we're going to flip-flop it, okay? So in a problem like this, I'm not going to do the whole one because we're going to get into the x and the y, two different variables, a little bit later on. But what I wanted to show you was just that you have to recognize that two things are being multiplied together. A more classic one might look something like this. And yeah, we can do these other ways, but we just recognize that these are being multiplied together. So what you're going to be doing, this is what the book says. It says the derivative of the function would be the derivative of the f times the g plus the f times the derivative of g. Okay? Well, technically, we can get rid of the whole f of x notation, just write f prime g, f g prime. But what I do is I kind of rewrite it a little bit different, and you'll understand why once we get to the quotient rule. But the product rule and the quotient rule are very closely related, so I do it this way. Basically, it's saying this. You're going to take the derivative of 1, doesn't matter which one, times it by the original second one. And then you're going to flip-flop them and add them together. So it really doesn't matter the order that you do things. You just got to remember that you are going to take the derivative of one of them, but not the other, multiply those together, and then take the derivative of the other one and the original and multiply those together, and then remember to always, always add them. So the very first couple problems, I'll actually write off to the side f, g, f prime, g prime. And then as you get more familiar with these problems, you'll realize we don't really need to write those down. All right, here's an example. Now, I want to talk about this just because you can do this a different method that we learned a couple lessons back. But there will be some times where the only way that you can do it is by the product rule. So that's why I just want you to do this according to the product rule. So off to the side, I would write that f, my first function, is 3x squared plus 5. Well, then f prime, the derivative of that, would be 6x. We're using the power rule. Okay, g is that second function, 2x plus 7. And then g prime, its derivative would be 2. So we need to use all four of these to come up with a correct derivative of the entire function. All right, so I'm going to do f prime g plus g prime f. And again, the reason why I rewrite this is because it's going to help you do the quotient in a few minutes. So f prime would be 6x times your original g, and your g is 2x plus 7, plus your g prime, which is 2, times your original function for f. So now we're going to go ahead and distribute, and we'll get 12x squared plus 42x, distribute, 6x squared plus 10. And we'll add our like terms. We will get 18x squared plus 42x plus 10. And there is our first derivative of the original function. Okay, on the previous problem, I had said that there was a different way to approach it, but I wanted you to do it using the product rule because at some point you would have to do the product rule. Here's that example. Here's the first thing, and it's being multiplied by the second thing. So I'm going to write f is t squared, f prime, well, what's the derivative here? 2t. Your g is your second thing here being multiplied together, so that would be sine t. Then g prime, okay, what is the derivative of sine? Think about that. We just learned it. Great. I'm sure you guys were all thinking cosine. So the derivative of the whole entire m function is going to be f prime g plus g prime f. So f prime is right here times your g, which is right here, plus your g prime times your f. Okay, now be careful here. Don't think that this is t cubed. Remember, this is one whole unit. You can't take that t away from the cosine. So I'm going to write it this way. 2t sine t plus t squared cosine t. And now, if I wanted to go further on this later on, hint, hint, we will be later on going a little further on these, I could factor out anything in common, which is technically a t. And that would leave me with a 2 sine t plus t cosine t. But if you don't do that at this point, that's fine. You just got to remember that the reason we factor things out is to try and do something more with them. All right, now let's take a look at this. This is considered one function. That's your f, and this is your g. So here's my f, and here's my g. So now I'm going to write down f prime and g prime. Notice how I'm doing this one slightly different. Instead of writing f and writing g and writing f prime and writing g prime, I'm getting a little bit smarter. So what's the derivative of 3 sine? That would be 3 cosine. And the derivative of cosine is negative sine. So let's start the product rule. I'm just going to keep rewriting the rule. You might want to keep rewriting it until you finally memorize it. F prime g plus g prime f. All right, so your f prime, look up there, is 3 cosine x. And you're timesing that by g. G is cosine x. Plus g prime. So find g prime. G prime is over here. It's like negative 1 sine x. And then your f is 3 sine x. Okay. Let's simplify cosine x times cosine x. I'm going to write it this way. This is a negative 1 times a 3. Sine times sine. And then again, if I wanted to pull out a 3, I could.